Okay, we're up to our next video. Let's get started right away. What we've got to do is variation. Okay, so we basically didn't even do it and hardly said anything in the previous video. So we're talking about variation, and the first thing we need to talk about is direct variation, right? So we're going to. This is our first direct variation. Okay, because then there's going to be something called inverse variation. All right, so we're going to see one problem, and the way it works is that there's a formula that you use for variation. It's very simple: y equals k times x, and in direct variation, this k has a special name, but I don't think you're going to have to worry about it. I don't think Alex is going to ask you that, but let's mention it anyway. Constant of proportionality, right? A little bit difficult to pronounce. Here we go, but I'm spelling it correctly, I believe. Yeah. Okay. So here let's show you a problem right away. So this is the formula. Y equals kx. That's sort of our intro, and let's go to a problem using it. All right, so let's say someone earns $95 a day. Okay, let's actually make it simpler. Why not? $100 a day. $100 a day. Okay. Now we have to. What if we're asked? Here's how they. Let me show you some of the phraseology of questions like this. Write a variation equation. Alex might phrase it a little bit differently. We'll see when you get to the homework of Alex, or when we get to the test. We'll try to prepare well for the tests, etc. Anyway, variation equation. Write a variation equation that describes the total pay that he's going to get in terms of days worked. Terms of days worked, right? So that's going to be the constant is going to be the $100 a day, but depends how many days you work, right? So then in terms of days worked, so that's able to change, and then describe after we get the formula down. Then how much does he earn in 15 days? Now, I know obviously you can do this easily with all this fancy stuff, but we need to be exposed to exactly the way they want to put it with this variation. This is direct variation. Okay, now I got a little bit more on the paper, and what they want us to describe is the y equals kx, and how does it work for our particular problem? Well, the y is going to be the total amount that has been earned. Total amount earned. Okay. Then the x is the number of days worked. The x is the number of days. So that changes and that changes, but there's the constant. X is the number of days worked. And the constant in our scenario over here, what's the k, the constant? The constant is this $100 a day. That's not changing. That his wages are not going up or down. So there is going to be the $100 a day. Okay. So that is how to describe y equals kx. So what do we have over here? The y varies, total amount varies. The equals does not vary, right? Y equals kx. The k is constant, so it's $100. And the days going to vary, how much they're putting him to work, how many days they're putting him to work. So that's going to remain as x. So there's our formula there's our y equals kx, and it's tailored to this description given over here in the word problem, right? Y equals k. Y is the total amount earned. X is the amount of days that the actually works, and that constant is the $100 a day. So y equals 100x. This varies and this varies, but this doesn't. That's the constant. So are we looking for 15 days? How much is which days? Is that the y or is that the x? Well, we described it here. X is the number of days worked. So replace x with 15. Y equals 100 times 15. Y equals 1500, and that is how much he can expect for 15 days of work. This is a case of direct variation. Okay, now we've got to show you something a little bit more complicated, which is the indirect it's actually called the inverse variation. Okay, let's go to a new piece of paper and discuss that. Okay, so when we are dealing with the inverse variation, so let me put the title up there so sort of to remind us that this is going to be a little bit different. The formula that we need to use for this particular case is y equals k over x. Okay, so let me give you a problem, and try to explain why do we need inverse variation and why we need that formula. Let me show you the word problem. Let's say someone wants to travel 378 miles. 378 miles to get to wherever they're going. As a matter of fact, let me not make it 370. Let me make it a much simpler situation. 360 miles. They want to travel 360 miles. That's what they have. That's how far they need to get there from let's say New York to where the Newark, New York City to Newark. 360 miles. Right? We're just making it up. Okay, fine. So now how do they phrase the question here? Write a variation equation. They don't tell us that they don't necessarily tell us that it's inverse. Hold on. But we'll get a hint anyway. Just bear with me for a minute. Right over here, describing driving time. Describing driving time. There's the time. Remember, when you're dealing with distance, you're talking about distance, time, and rate of speed. Driving time in terms of speed. Okay, and now if they want to be generous, they'll give us a hint that we're going to need inverse variation, because the time it takes to drive a certain distance is going to be varies inversely with the speed. So let me put that in writing and then explain it a little bit better. The time it takes to drive a given distance, right? The same distance, that's going to be our constant. The distance is going to be our constant, a given distance. You already have, or a certain distance, a given distance. You already have an idea that the k is going to be our distance, to drive a given distance. It varies inversely with the speed. Varies inversely with the speed. Okay, let me explain a little bit better now. It makes a lot of sense. If you're going, you got the same amount of miles you're traveling. If you go faster, it's going to take less time. If you go slower, it's going to take more time. Okay, so what does that translate for us? Our y is going to be equal to the time it takes, time traveled. Let me move up this page again. Got to get that page up. I don't want to lose anything here. The x is going to be the average speed. average speed, and the k is the constant, which is going to be the distance traveled. In our case, it's 360. Okay, because our k is the constant, which is the 360. That's what we keep constant right there. But this is we're interested in the time, and it's going to be the inverse of the speed. The faster, then the less time. The slower, more time. Okay, now what do they want to ask us? What if you're traveling? Wait, how much time? Here's the question. How much time does it take at 60 miles per hour? Okay, y equals k over x. That translates into y equals, how much is our constant? We're talking about 360 miles. What are we given? The average rate of speed. X is the average rate of speed divided by 360. So this turns into y is equal to 6. And we're talking about an hour. So y is equal to 6 hours. It's going to take 6 hours. The time traveled. The final answer is 6 hours is how long it's going to take to travel at 60 miles per hour if you're going 360. This is a case of inverse variation. Okay, so when we get to the test, we'll see what type of questions they'll give us in this way, and we'll try to prepare for those particular questions. But those are the basics of inverse variation and regular variation. Now, if I have a little time left, what I need on this particular video, we can go to starting the coordination system, which is as follows. Let's go to a new piece of paper, and here we go. Okay, so we're dealing with 6.3, not the coordination system, the coordinate system. It might sound hopefully some of this sounds familiar. Cartesian graphs, coordinate system, etc. Okay, let me show you the basics. We're talking about 6.3 in your book. So the title is Rectangular Coordinate System for the moment. Rectangular. That's their fancy name. I would just call it the coordinate system. But anyway, rectangular coordinate system. All right, we can get started. We'll have to finish on the next video. All right, so here is what we need to get started with. You've got a y-axis, which is a vertical, and an x-axis, which is horizontal. And now we need to so there's some vocabulary. I'll probably put it on the next video because we're going to be running out of time soon. But I think I can get on this video the basics of what we need to get started, and we need to plot points. And let me tell you which points I want to show you. It'll basically tell you everything you need to know. Okay, we're running out of time. I'm going to show you the points. We're going to have to do all of this over again on the next video. These are going to be the first 4 points to show you how this maybe this looks very familiar to you, of how to plot points on a Cartesian graph. All right, all of this on the next video because I can't go over 15 minutes, as you well know.